If you're building, architecting, testing, doing anything with AI agents this year, you're going to want to check this out. So Anthropic just released a super in-depth article going through everything that they use to build their multi-agent research system, which I assume is like their deep research product. Um, and I've gone through it basically like 3 times at this point, and it's super helpful to see how they architect things, how they break things down. We'll go through everything. We got some nice, cool little diagrams to kind of check out here. So again, if you're building agents or just want to learn about agents, this will be helpful. It won't be too technical either as well. So going through it, Claude has research capabilities, means you can search across the web, Google Workspace, and integrations. So, and integrations basically means MCP in this case. And they use a multi-agent system to do this essentially. So they have an agent that plans a research process based on whatever the user is asking, and then uses tools to create sub-agents and search for that information simultaneously. And they came up with this approach because essentially when you think about doing research, each agent can kind of do its own thing. Usually when you're doing some research project, there are a lot of different just areas you need to go check out, and they're not too like interrelated or dependent on one another. And so that's what they kind of mention here. The essence of search is compression, distilling insights from a vast corpus. Sub-agents facilitate compression by operating in parallel with their own context window, exploring different aspects of the question simultaneously. So each agent has kind of separation of concerns here. It has its own tools, prompts, context windows. So you're separating that versus trying to have like one do everything. So again, multi-agent stuff works well for breadth-first queries and involves pursuing multiple independent directions at the same time. So researching different areas at the same time. They use Claude 4 as the lead agent, Claude 4 Sonnet as sub-agents, which outperform the single agent Claude Opus 4 by 92%. Let me make a note of that. So multi-agent, do 90% greater than. 3 factors explain the performance. Token usage itself explains 80% of the variance. So that's pretty crazy. And what does that actually mean? Number of tool calls and model choice were the other 2 factors. This finding validates architecture that blah, blah. The latest Claude models act as efficiency multipliers on token usage, as upgrading Claude 4 Sonnet is a larger performance gain than doubling the token budget for 3.7. So yeah, the Claude 4 model is just a lot more intelligent. Multi-agent architecture typically scale token usage for tasks that exceeds the limits of single agents. So obviously the more LLMs you throw at something, the more tokens you can use to solve that problem. And that's generally what they're saying here, both in terms of, context windows, max outputs. There's always like a level of information, I think, before the context window at which an LLM becomes overwhelmed. And so rather than having, a single LLM do the whole process, which we'll actually look at in a second here, you break it up and you make it like kind of much more chunked in like kind of smaller sizes. And so downside is this costs lots more money. 15 times more tokens than just like regular chat for a multi agent system versus 4x for just a regular. And kind of what we touched on before, domains that require all agents to share the same context or have dependencies are not good fit for multi-agent systems. So you can think about like coding tasks, right? Usually there's a lot of dependencies between files, and having agents touch different files that the other ones are working on is just gonna have like a bunch of conflicts. And so that's why research is actually really good for this. Cool. So they call it orchestrator-worker pattern. Orchestrators on top, workers are beneath. Lead agent coordinates the process and delegates. So let's go over here to something that I thought was a little just easier to look at. So our user query is what are all the companies in the United States working on AI agents in 2025? Make a list of at least 100. Get the the name, the website, what they build, the type of agents they're doing and stuff. And so a single agent, this would have been all kind of just one. In multi-agent setup, we have the lead agent that's going to plan, create these sub-agents, aggregate the final output, and handle retries and kind of looking over things. And we're going to look at the prompts in and output in a second here. So in this case, let's go over to, so I have they published their prompts, which is great. And so the cookbook will be below, and then I also just added it to PromptHub so I could run it, and you can run it yourself. So again, the system message here is everything from Anthropic, and then I'm just adding that query for the user here. And now let's see what the output is from that. So this is the same query that we just saw on the screen. And let's make me small, put me on the other side. So this lead agent is going to break things down. So it does like some strategy stuff and like understanding of the topic. Main concepts, agents in 2025 in the US. We want to have a well-structured report. Breadth first query, as it requires gathering information on multiple distinct companies and their AI activities. First, this is gonna create a sub-agent to identify essentially the top, 100 companies. So this first sub-agent is just going to find those 100 companies. So that's what we're gonna see here is find the top 100 AI agent companies. That's all the first one is gonna do. Nothing more than that. No more deeper research than that. Then I will create additional sub-agents to research each company in that list of what the 100 and find those details. So sub-agent finds the top 100, and then we'll see this later, but it spins up 15 sub-agents to then look at things like website, products, and vertical and industry. To ensure coverage, I will create additional sub-agents to then search for any other companies that were missed in the initial list, focusing on blah, blah, blah. So it essentially then has like these kind of like additional sub-agents to kind of like fill the gap, check the work, see if like maybe this one missed the industry, this one missed the vertical. It will fill those in. Parallel tool calls. I will start deploying my first agent. Here is the instructions. So it's going to generate instructions for each one of these agents. Research top companies, get a list of the top 100, blah, blah, blah. Provide the result in a format that can be easily integrated into a final report. Once the subject is completed, I will deploy additional subagents to research each company on the list in more depth. So research company name, essentially just get more info. Repeat this process for each company on the list. Once it's complete, make it into a final report. Some formatting stuff that's not super interesting. Research process. Here we go. One agent to get the list of 100 companies, 10 to 15 to research each company in depth on the list. Boop. There we go. And then potentially, so this is up to the lead agent, 1 or 2 sub agents to identify gaps. I will deploy the sub agent to get the list of 100. Once that completes, I'll deploy additional sub agents. So there's a little bit of like feedback loops going on here. Anything else? Yeah, the direction about like how to do the search. Available internal tools. It basically just says only use web. To do guidelines, review the facts, stop creating agents once you reach the final endpoint. It will generate the final report, not in the sub-agent. Here's what it looks like. Example. And yeah, so this is what that output looks like. So again, this is what the breakdown looks like. Once it's like complete, the lead agent again is going to look at this report, and if it's complete, that's good. Anthropic has a citation agent that it would want to send this to, and then it notes in the article. And then that's basically just going to add the correct citations so that everything is all good. And then it gets a final result that goes back to the user. If it is found that this like initial list is not good, it can either generate more sub-agents or refine that strategy, coming back up to the lead agent. So the lead agent will look at that final report and decide if it's good or not. And what's in this orange field is essentially the research loop. There's probably another arrow that happens actually like this. Yeah, that's right, actually. Here and here, where I think the lead agent actually said it was going to review the sub-agent 1 before moving on. So there are other loops kind of happening within this as well. That's generally what it looks like. And again, if you had a single agent, this would be all encapsulated to like a single vertical box here where you have to find all 100, find all the data, make sure it all looks good, reason to verify, fill in any gaps, and then send it to, or then actually, you have to also add your own citations because you're just doing this as a single agent. And you can just see the chances of something being wrong here is going to be, I'd say, much higher. effect of LLMs that like they can't really handle too much at once. The more that you can break down things into these kind of, you can call it multi-agent, you can call it just like a delegation of tasks and spinning up LLMs to do like many different things, and then there's just a level of like orchestration around it. The more you can do that, make those things much more like bite-sized and smaller, the better output you're going to get. So more specialized agents, smaller agents, and using many of them. And so that's generally the architecture. So prompt engineering, fun stuff. So my favorite part of the article, since each agent is steered by prompts, prompt engineering was a primary lever for improving these behaviors. So prompt engineering is not dead as much as people would like it to be. Below are some of the principles they learned. Think like your agents. So this is a really big one. What this really means is just like really understanding the task as if like you had to do it, And like I think that's a good like something that we tell people to do is like if you were to give your colleague the prompt, which is basically just a set of instructions, would they understand how to actually go ahead and do it? And would they produce something that's like to your liking? So really trying to think how your agents are acting. What's their context? What do they need to do? What tools do they need to like have in hand to actually accomplish what needs to be done? Having like a good mental model is huge here. Teach the orchestrator how to delegate. The lead agent decomposes queries into subtasks and describes them to sub-agents. Each agent needs an objective and output format guidance. So again, each agent needs these things. That's again of like having a correct mental model of like what does the agent actually need. Without this, so basically the orchestrator needs to be able to create these really detailed tasks for the agents. We started by allowing the lead agent to give simple short instructions, and that didn't work. Like research a semiconductor shortage, they were too vague. And so they misinterpreted the task and then blah, blah, blah. So they had to do less. They needed longer instructions to make the like proper like details come through for the sub-agents to do the correct research. This is really nice. Agents struggle to judge the appropriate effort needed, so they had this kind of embedded scaling rules in the prompt. And we can look at this in a second. Actually, we'll look at it right now. And so this is cool because it's not a lot where they use like frameworks and like heuristics versus like hard rules. So where is this? 3, it's 10. A lot of 10s. Here we go. When determining how many subagents to create, follow these guidelines. For something simple, use 1. For something standard, use 2 to 3. For medium, use 3 to 5. For high, use 5 to 10. And again, these aren't like hard and fast rules, right? These are like a framework which can be helpful for situations that are like in between. Let's see. Blah, 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 blah. Yeah, these explicit guidelines help the agent allocate resources, prevent overinvestment in simple queries, which I think happens a lot. Yeah, it's a common failure mode in early versions. Agent tool, blah, blah, blah. Using the right tool is necessary. For instance, an agent searching the web for info that is only in Slack is doomed. Yeah, I mean, this just is something they repeat a lot, is that you need to spend as much time on your prompt or as like the tools and the descriptions, because those are like really, really important. You should almost think of it as like documentation for like a tool, and really have those be crisp, clear, have examples of when those are used. Like Anthropic's been really good on pushing this, and it's like super important for any agent. And again, they do heuristics here. Examine all available tools first. Match tool usage based on user intent. Search the web for broad external exploration, blah, blah, blah. Bad tool description can send agents down the wrong path. This is totally true. Let's see if this can be maybe not the best thing to search for. Let's see if there's a header for these that we can find quickly. Yeah, I mean, look at all this. Use available internal tools. You may have some tools. For instance, you might have this. You might have that. Like there's a whole bunch of sections about just like using tools in parallel, in a lot of direction here. Let agents improve themselves. When given a prompt in failure mode, they're able to diagnose why that happened. Totally should be using LLMs in the prompt engineering process. Start wide and narrow. Agents often default to overly long specific queries that return few results. We can counteract this tendency by prompting agents to start with the short, broad queries, evaluate what's available, then narrow the focus. Yeah, I mean, I think especially with reasoning models, you see this a lot where like they burn a lot of tokens reasoning, and I feel like that leads to like a lot longer outputs from them. And so in this case, that was the solution. The lead agent uses thinking to plan its approach, assessing which tools fit the task, determining query complexity and sub-agent count, as we saw when looking at the output there. Sub-agents also plan and then use interleaved thinking. So extended thinking, which I think I mentioned here, extended thinking for the lead agent, interleaved thinking for the sub-agents, probably because the sub-agents are using tools more. Yep. Early agents, yeah, parallel tool calling makes things go faster. It's like the headline. Lead agent can spin up 3 to 5 in parallel rather than serially. Sub agents can call 3 plus tools. This cut late, time by 90%. Good win. Again, good heuristics rather than rigid rules. And looking at how humans would actually do this. I can imagine someone from Anthropic sitting next to like a researcher or many researchers and just seeing what they actually did and trying to mimic that into their system, which is like a great way to do this. You're seeing this a lot with like forward, what is like now very popular, which is forward deployed engineers, where they will, and founders take this role too, where they'll sit down next to the person, see how they do the task step by step, screen by screen, click by click, and then try to translate that into their product. All right, next up is the evaluation of the agents. Again, yeah, these are tough because we don't always know the right steps. We can't, like an agent can take different steps to get to the right answer. So you can't look at the steps along the way, but you can't look at the outcome. So you can see whether they achieve the right outcome while also following like a reasonable process. Something they note is to start evaluating immediately, even if the sample size is small. In this case, they only have 20. It's totally fine. They mentioned that they've heard people think that they need large eval sets. I've seen this too. But again, start small. Doesn't matter if you have 10 or 20. Start with something because, yeah, there's usually a lot of low-hanging fruit that can get you from like 30 to 80% here. LLM as a judge. So, listen, I love LLM as a judge. I just see a lot of people not do it correctly. And I think which is the important part, which is done well. And it works well really in this case since, research outputs are evaluated programmatically since they're freeform. And there's not usually a correct answer. And so LLMs are a good fit here. And what they eventually did was LLM as a judge as a rubric about factual accuracy, citation accuracy, a couple other things. They have the LLM judge from 0 to 1 and give a pass-fail based on that. And I think I put that in here somewhere. Yeah, so you can imagine this being like the output. And then if the input could have been something like, evaluation agent, read the following output and evaluate across multiple criteria. Then maybe they gave a definition of each. And then again, the scoring structure, output format, and you get something like this. Human evaluation catches what automation misses. Yeah, this is huge. Like you need to have some level of human involvement in looking at actual outputs. They mentioned here that agents would consistently choose SEO optimized content farms over like highly ranked sources like papers and stuff, just because it's looking at like maybe what's ever on top. So then it baked that into the system instructions of like reliability in their sources, which you can see in the prompt itself. This, small changes lead to agent, blah, blah, blah. Best practice for these agents are not just strict instructions, but again, frameworks for collaboration that define the division of labor, problem-solving approaches, and effort budgets. So again, heuristics and frameworks, not rigid rules. Bunch of other stuff. This was interesting. Synchronous creates bottlenecks. Basically what this means is it's currently running in sync, so it's waiting for each agent to complete before proceeding. So the lead agent can't it can't really steer the sub agents. The sub agents can't really coordinate amongst one another because they're all working at the same time. And then the whole system can be blocked while waiting for a single agent to finish. So for example, if this agent over here is looping, caught in a loop, just continually going, we have to wait till it's fully done to kind of move on to the next step. And it'd be great if it was async. That has a lot of challenges, and now you have this whole like coordination aspect that you need to keep up and more states to kind of track. State consistency, error propagation, and at least as of now, they chose to not go ahead and do this. So let that be a signal to you. And this is true. The last mile is always like the hardest. That last 5, 10%, 2%, 1% gets increasingly hard. And so just be aware of that going in. And then the last couple of like things in the appendix that actually jumped out. And state evaluations that mutate over many state turns. So this is basically saying, agents can take many different routes to get to a final answer, but you can still look at the end state. So we found success focusing on end state evaluation rather than turn-by-turn analysis. Instead of judging whether the agent followed a specific process, evaluate whether it achieved the correct final state. This can be tricky because if it's getting to that final state, but the way that it gets there is like completely wrong, that's something you need to be aware of. So that's where it comes back to like, hey, you need to have a human looking at these things as well. Conversation management. So yeah, conversations get really long, hundreds of turns. You need to compress, and use memory. They essentially did that with patterns where agents would summarize completed work and store essential information in external memory before proceeding to new tasks. So they had some like external memory that they would shoot really important info off to, like the lead agent's strategy of accomplishing would go live in that memory, so it's always retrievable and doesn't get condensed by a summary after a certain context window fills up. Yep, retrieve stored context like research plan from the memory rather than losing previous work. And this is the same for the subagents, where they can output to a file system. So subagents can bypass the main coordinator for certain types of results, improving performance, essentially implementing like artifacts where agents can create outputs that persist independently. So again, it's like shooting it over there. Subagents call tools to store their work in an external system and pass lightweight references back to the coordinator. So you can imagine a file and a file ID for code reports or data visualizations. And that gets us to the bottom here. So again, one of the better, if not the kind of best, like step-by-step, tons of information about how to actually build a multi-agent system and why it's helpful and when it's helpful. So a bunch of resources below. I hope this was helpful for you guys. We're going to be doing a lot more kind of agent content as we start to build out our prompt engineering agent in Prompt Hub, and we'll share a bunch of content along the way. But I hope you enjoy this and happy building.